Good day, everyone. Welcome back to Digital Ag Global, your go-to podcast for everything technological in agriculture around the world. Today, we're going to be turning our attention to one of the quieter but more consequential shifts in digital agriculture, the rise of smart algorithms behind the dashboards, the carbon reports, and the agronomic recommendations that growers and agribusinesses now rely on every season. For a long time, technology of this kind has been a marketing line and in many ways kind of theoretical. But we are now starting to see how this is something more serious. We're seeing scientific models, machine learning, and agronomic data combining into forecasting and intelligence systems that could stand up to scrutiny, reliable, defensible data from a farmer in the field to an auditor verifying a carbon credit. Yuri?
Hi, everyone. Thank you for sticking around and watching our podcast on season 2. And as Clyde mentioned, today we're going to try and look under the hood and understand what does it take to develop a scientific model in agriculture, how to build a smart algorithm, what type of intelligence or forecasting it can bring to the table to help farmers gain better yields, better ROI, or be compliant with different regulations. And we have a great guest, Tatiana, to help us with that. But before we introduce our guest today, I just want to remind our audience that Digital Ag Global as a podcast, as a platform, offer partnership opportunities. So if you want to become a part of our network, have access to speaking opportunities, to all the insights and all the speakers we had so far, feel free to drop us a line, help us to promote AgTech worldwide, and we'll get you sorted.
All right. Well, thanks, Yuri. Today, joining us is Tatiana Boussange, Director General and Co-founder of Armosys, a spinoff of the University of Milan that has turned more than 2 decades of agronomic research into ARMOSA, a process-based modeling engine now used to power carbon, climate, and productivity decisions, and to provide defensible data throughout agricultural supply chains. Before we get going with Tatiana, I just want to remind the audience that if you have questions or comments, we'd really like to hear from you. So please enter those into the chat. So with that, I'd like to invite Tatiana to tell us a bit more about Armosys and the journey from university research to a commercial engine and what brought you personally into this space.
Thank you very much, Clyde and Yuri, for the invitation. It's really a pleasure to be with you today. And also, I hope the audience will enjoy and learn something today with us. So definitely, where I come from, very simple. I've always wanted to be working in agriculture. So I operate in agribusiness for the last 15 or more years, working for large corporates in the crop protection, fertilizers, and now I went through a startup before I joined Armosys. That was a project developer of carbon programs in Europe that issued credits as well, actually just 6 months ago. And now with Armosys, I'm on the other side, where we are basically a service provider to project developers or food companies, as well as precision ag platforms, in order to either provide decision support systems, at least data and insights that help them build them, or measure carbon and nitrous oxide emission reductions on field or in supply chains. And your question on how did Armosys come up and how does it connect to the university and research? It's an interesting one. That's actually why I joined the company. And when the concept came up, is you have just a few process-based models in the world that are really robust and that can provide you a lot of insights. Among those, you have the NDC, you have Decent, Century is a version of Decent. I can name a lot of them, but only a few have been commercialized or are made available to businesses, because it's not enough to have just a model, a science, but it's to actually adapt it to the use cases, to calibrate it, validate those calibrations, so make it believable, credible, and also make it available through infrastructure and scalable. And so that's the big challenge, or for any university to become basically a business, it's impossible. That's why you have spin-offs, and that's where Armosys came to become the system around the ARMOSA model.
Well, that's great. I mean, I think universities are increasingly becoming incubators for more commercial startups, and it's an interesting process. And it adds a lot of value to the economy and to efforts like this. I find it very timely that we're having this conversation today, and that in Canada, a non-government organization called Nature United has recently come out with a discussion paper on Canada's natural advantage and measuring essentially the environmental goods and services in farmland, forests, and indigenous territories in Canada. And one of the challenges, of course, they identify is collecting the data and then also processing it. That's kind of work you're engaged in. Maybe you could just take us back a little bit, as you said, behind the hood. Maybe you could just talk a little bit about what an algorithm is and what is the difference between just an algorithm and a smart algorithm.
Yeah, this is a tricky question for me, because although I'm behind Armosys, I am absolutely not a tech person. I'm more like a business oriented person, strong in MRV. I mean, understanding concepts of MRV. But you already prepared me for this one. Before I go into algorithms, if I may step back and answer the previous question, because I realized I didn't answer it fully, is like, what does it take to actually build a model? And the thing is that you mentioned the universities are really incubators, because universities are the only ones ready to do the long-term, really necessary work to, one thing, design the models, then measure them in fields, because agriculture, as we all know, it is a seasonal topic. If you miss something, you miss a year. If you make a mistake, you miss a year again. You cannot make it up. So the timelines of development and innovation on these aspects is always longer in agriculture. And I think that's why AgTech and startups in AgTech usually require a longer term for the return on investment when you look at it as from an investor point of view. Mm. The University of Milano developed the ARMOSA model. I mean, it had a different name, but it basically started 20 years ago with our inventor, the Professor Marco Acutis, and he basically started it all. And the outcome of this is that you have a model that is like a symphony orchestra. And I will explain why I like this image. When you talk to decision support systems or precision ag platforms, each of them will have one focus and specialty. I will do variable rate applications. I optimize nitrogen compared to or I optimize your nitrogen efficiency of takes or your yield and your inputs. For this, you can use a simple model involved. I mean, you can even calibrate the Wolfhost, and that's basically it. But then you will not have that model really calibrated for any other aspects of your crop. When a process-based model like ARMOSA is considered in this approach, you basically have to model how the crop develops on a daily basis in interaction with its specific soil and the climate that you have on a daily, or weather inputs that you have on a daily basis. So the model simulates every single process that is physicochemical that happened on that crop or for that field or that supply chain. I mean, we can be as granular as the data gives us the possibility. And when you do this, you basically know exactly when your results are not fine on one aspect, you know exactly where the blocker can come from. And why the analogy with the symphony orchestra is that when you do a Wolfhost or a kind of specialized nitrogen optimization model, it's like you play the violin. Later on, you might want to optimize something else like your fuel consumption. Fuel consumption is a bad example, but your seed rates. or your growth, or your tillage activities. Then you will plug in the piano. But then you need to make the piano work together in harmony with the violin, and then it becomes tricky. And when you work with ARMOSA, you already plug in the whole orchestra, because the violins and the piano are already in harmony, since everything is modeled. It's only a question of what is your focus, where do you calibrate specifically, and what kind of data input you have at hand to be reflecting the accuracy that you look for on that specific output. So I hope I could clarify. Feel free to dig in.
For sure, you clarified. Clyde, you're on mute if you're trying to say something. Yeah.
Sorry, I just had some sound in the background there. So I think you kind of have, through that analogy of a symphony orchestra, give us some insight into what a smart algorithm, is. And maybe Yuri, you could jump in here, and from your work.
For sure. I wanted to comment, and I also like this analogy with orchestra. And I think like 10, 15 years ago, all of analytics, or most of the analytics for agriculture or AgTech, were focused around showing one metric or one unit that is important for agronomist or a farmer or a farming company, co-op, whatever it is. And it was like, I don't know, GDD, evapotranspiration, weather forecast, etc. Just a standalone metric that they can interpret by themselves based on their experience, yada, yada. And that's a very simple algorithm that you can show. Mm-hmm. Or just show a growth stage based on GDD. That's also a very simple algorithm that you can use in your AgTech solution. But when we have more sophisticated algorithm models, forecast engines, whatever you call them, they combine this simple metrics together in order to generate a higher level insight, forecast, intelligence for a farmer, whether it's a nitrogen uptake, whether it's a carbon metrics, whether it's a yield prediction or pest disease or something, pest and disease control and warning. So, and that's where my general take it. That's where everything is moving. We are kind of moving away from a simple metrics, and we are trying to showcase metrics that are actionable right away. You don't need to analyze them by yourself. That's kind of what smart algorithm means in my head.
So I think when we're on a crop production farm, there are inputs that come into the farm that have carbon associated with them. And then the actual production system can release carbon, whether that's carbon dioxide or whether it's nitrous oxide or other greenhouse gases. So Tatiana, obviously you're in the commercial side of things. What is the commercial value of what you're doing? And I'm assuming it's really you're giving people some certainty to be able to monetize, get value from better practices that reduce carbon and other negative environmental outcomes.
And when we talk about carbon, some people in ag can have suddenly their hair, the goosebumps, because like, oh, again, yes, these environmental parameters coming up, they're really everywhere. The reason I joined the carbon markets 4 years ago was because carbon is basically 58% of organic matter. I mean, organic matter contains 58% of carbon. So if you increase your carbon, you basically show that your soil is depleting less, or it even improves in quality. So I look at carbon as a proxy for soil health or soil regeneration. And the market starts to understand this, because you see now that carbon programs are, I wouldn't say rebranding themselves, but they're trying to be a little bit more holistic or more pragmatic in that term. That they're not just looking at carbon, but they're looking at carbon as the proxy for better soils that will then bring either healthier food, so more nutrient content, or in your vegetables or in your cereals, or also a reduced. How to gain the same yield with the same, lower inputs or lower cost, or for the same cost but with more profitability, and then how to help farmers also finance that their practice improvements or farm management practices. And that's where the carbon markets come into the picture. Because when I come back to the carbon market, you have on one side in Europe, you have the ETS market, which is a mandatory one. It's like a quota to pollute in a way. But you have also the other way, that is like the voluntary carbon market, which is not regulated. It's a voluntary, as the name says it, where you basically are rewarded for reducing your emissions on one side, or rewarded for storing carbon in soil, looking at it like a sink. And that's what we measure as well. Initially, actually, Armosys was built to be a carbon measurement tool, but as I mentioned, ARMOSA, the model behind, is capable of much more. Mm-hmm. Now, on the carbon topics, today you have two ways of looking at it. You could do estimations in a very simple way, but nobody will pay you really for estimations, only to justify the fact that you're going to maybe invest in a carbon program in the future. So if you want to have some finance, some dollars moving from one pocket to another, you need to build trust in that market. What am I paying for? Why can I trust it? Where does it come from? And how is it going to be used? And that's where we come in the picture. We are one among many, many players in that, or many stakeholders in that supply of carbon units. So the people who basically will buy those units, they will want to see a project that is reasonable, and the project is reasonable because of its location, what it does, what it improves on a social or environmental aspect, then how it's being audited, under which methodology this project will be basically issuing those credits. And the methodology usually defines a minimum level of MRV quality. I don't know if the audience is familiar with the term MRV. I'll just summarize it quickly. So it stands for monitoring, reporting, and verification. So it's basically all the technologies, and not only technologies, can also be just a verification tools or statistics that you can put in place in order to prove that what you measure and the data source of it is trustable and really happened. So. And we are here just one in the long chain, but one important player, transforming the data into that quantification that everyone wants to trust and will trust. And that's where we stand as a science engine.
Right. So I think it's interesting that, I think both of us have been involved for decades in work related to trying to improve carbon performance on farms. In my career, it was related to fertilizer efficiency. I think the difficulty in trying to create financial, instruments and benefits from what we saw as good practices, perhaps outstrip the capacity of the technology and our measurement and our computing capacity. It just wasn't enough 2 decades ago. Do you think we're at the point now where we can overcome this hurdle with technology like with our ARMOSA?
Yeah, it's an excellent question. I remember being in the ag sector 15 years ago, looking at all the beautiful tech, the digital tech out there, and I didn't know what to do with that. And most of my customers, when I was selling to farmers in Czech Republic, Slovakia, which are large farms for European standards, most of my customers were like, "Yeah, I have a farm management software, but I don't know what decision to make based on that. It's a beautiful screen, gives me information, but what for?" So it basically became quite quickly a reporting system for subsidies, and later on with the interoperability of data, like when you do variable rate applications, then there it made sense. But it was always very difficult to implement it at large scale everywhere and automate it. And in the end, the farmers, I think this is no news for anyone, in the end, the uptake on technology was slowed down by the number of times they had to put into different platforms the same data. And technology today brings an opportunity to, at least for farmers, to have one platform. Later on, we'll discuss about this. I guess that's maybe where I see the role of AI. But how farmers can make their life easier and at the same time then benefit from multiple services from the same data point.
Yeah. So could you maybe talk about the kind of companies that can benefit from the kind of defensible data that you're producing through ARMOSA?
Yeah. When we look at when we look at defensible, it really means that it's a data point that you can trace back. So when I look at some AI modeling, then if you ask the provider to reproduce the same, or to prove where this data, how it was calculated, where it got from, it's not always that easy to prove where that comes from, and which processes hide behind the outcome or output you have on reported. So that's the beauty of Armosys, is that we still use and will always use ARMOSA as the real engine. So it's a real process-based model, which basically integrates, knows exactly if you change one parameter, if something changes due to weather, in, for example, evapotranspiration, the plant will enter into a different mode on other activities that the model models, and then it will impact the other aspects automatically of the growth, the plant growth, or the carbon development, because carbon is based biomass. And the defensibility aspect is that, how do you prove that the measurement is according to the methodology? So if, for example, you issue your carbon credits under an ISO or under a Verra standard and their methodologies, then you have to prove that it's aligned with what these methodologies define. For this, you need to undergo a model calibration very specific to the projects or the area and the combination of practices. Whether you're modeling tillage changes or nitrogen reductions, can also be the presence of cover crops and what type of cover crops. So these are the things we would basically model, and if you implement the cover crop for over winter, like for 6 months, it's going to give you a different biomass and growth. I mean, the model will basically model the plant growth for that period, the type of termination, and if the cover crop is being harvested or desiccated and then harvested, and it will also change the way the carbon is then accounted for. But I'm talking about carbon, it can be anything else as well. Mm-hmm. So you need to have these aspects basically covered from a scientific point of view. So that undergoes different audits, whether it's an audit by a scientific modeling expert, and then supervised by some other validation bodies. Let's keep the simple word of auditors. And they need to be reported. And if you have questions later on in the different audit steps, you need to prove how you got there. Since carbon, for example, we're talking about carbon, so since this one is not something that easily detectable in the soil, because the growth is so small, you cannot measure it on a yearly basis. So you usually measure it every 5 years at least, in order to have enough quantity that justifies that covers or makes up for the sampling error. So when you sample, you have a human factor, you have whatever error factor, and that can be bigger than the evolution of carbon in the soil. So that's why you don't measure it on a yearly basis. First of all, it wouldn't be financially viable. Second, you wouldn't detect that evolution of carbon. So that's why you either do a remeasure that you sample and resample by at least 5 years, but then you will have to wait 5 years to issue your credits. There are some new technologies involving remote sensing and digital maps that appeared when were approved a few months ago. That also enable to make this financially more viable, but it's still a new science. And otherwise, you would use models like where Armosys comes into the picture to basically tell you what to expect on a yearly basis, and then you need to just match your expectations after 5 years in the true-up sampling. Additionally, you would calculate an uncertainty deduction, like a penalty for inaccuracy. That is not only related to modeling or the model, but it's related to other aspects that will feed the model or be involved or related to the sampling design, basically how you would design your sampling campaign to be representative of your project.
Right.
I maybe go too far in technicities on that aspect. It's just to say you cannot measure it that easily and detect it. You need a model. In order to trust it, you need to undergo a lot of audits and adjust the measurements to methodologies. And I would say that's also the difficulty of these carbon markets. Like you cannot just say, I have a model, I can do carbon. Well, you can do carbon, but you don't know how to prove it, because you will have to have the infrastructure and the knowledge of the methodology and the capability to adapt to those. So it's a specialty in itself.
Right. And of course, there are a number of different kinds of greenhouse gases. I mean, everybody thinks of carbon dioxide as sort of the benchmark. But I mean, I like to think that when you are measuring carbon dioxide, you measure it by the tons or the kilogram. When it comes to nitrous oxide, which is a very small emission, but it's a highly potent greenhouse gas, and nitrous oxide can be a byproduct of fertilizer use. You're talking grams, not kilos or tons. And so, your measurement and your error can be very, very significant. I just wanted to also come back, though, to about verification. Generally, I think the experience has been that farmers are not thrilled about audits or verification. But the more accurate and trusted your model is, I'm guessing that the less the requirement is for verification and audit. Like maybe it's on a longer scale or less frequent or things like that.
I would love to say yes on that one, Clyde, but unfortunately, the methodologies are built in such a way that the type of MRV player will not change the scrutiny that the auditors will put on our customers to prove that everything was done well. When I say our customers, because our customers in these kind of programs are then the project developers. But however, there's a benefit in having a more robust or a more credible partner than another. First of all, when you're a project developer, like when you select your MRV partners, among them Armosys, you want to be sure that you don't run into risks. Risks of failure, like do they have the infrastructure? Do they have the knowledge? Will they be here in 5 years to do the necessary work again? Do they understand me? And do they understand the methodology? Or am I to tell them what to do and then they just compute like a dummy calculator? So this changes everything in how you will be successful as a project developer in the implementation of your project. And yeah.
Oh, go ahead. I was just going to turn to Yuri, though, and ask Yuri, what are the challenges in gaining that level of confidence, trust, accuracy, however you want to talk about it. And so what are those challenges and how close are we to sort of really overcoming those in the back end of these systems?
Well, If you're talking about models that can verify carbon programs, that's, I guess, the answer that we hear from Tatiana takes 20 years of scientific research and then a long path to commercialization. But I would look at this more from a technological standpoint, and I would also kind of give it a bit of a data integration twist, because most of these MRV solutions or models, they rely on generally available weather, soil types from soil grids usually or other providers, and then they also use satellite imagery which comes in AgTech space from true providers, Sentinel, Hub, or Planet. Same company own both providers. And then the last one, the most important one, is actual farm operations. What have been done on the field, when it was harvested, when the seeding was done, what type of tillage, when, yada yada yada, what fertilizers applied, what treatments applied, etc. And that's where the biggest problem comes in terms of data integration, because in some regions people gonna use same farm management system and they will have API available and you'll be able to use it. In some cases it's gonna be a written history of operations in some spreadsheet that you will need to parse to spreadsheets and then pull into your model to verify. In some cases it's gonna be something else, and this data integration becomes a very annoying, a very long-term process, which takes a lot of time, a lot of engineering resources or engineering talent to get it done. And that's the biggest problem. Once we have a unified way to gather all this data from different data sources, solutions like ARMOSA can benefit even more, because they will have a standardized data sources that they can plug in and use, and then calibrate to regional specifics or to regional nuances of a country, region, farm, whatever it is. So data integrity and reliable data sources, that's the biggest question for, in general, MRV solutions. But it's getting better and better. Data integrity in general is a very big question in the European Union. A lot of efforts towards having a unified, standardized way of handling ag data. So those solutions going to be highly popular in near future. They are popular right now, and that's something we've been working with as well.
Right.
Yeah, it's a very strong point you're making. That's usually the there's this new technology related to remote. I mean, you have remote sensing. Let's look at remote sensing as an example. Whether it's in the carbon projects or for productivity insights, because I'm always looking at Armosys is a dual offer. On one side, we are doing the defensible carbon measurement, like for carbon programs with all the science that is behind. On the other, how can we make farmers make better decisions by providing them the scenarios on productivity? And the two are really separate solutions, although they source from the same model, because you look at it as I am optimizing my approach and my data on a very different objective, because the model can give you 100 outputs, like on a daily basis, but you don't need those 100. You will just flood on the data. You just need the things that make sense and that will help you make a decision. And that's where calibration is also important. Like you will, if I'm looking for optimizing my yield forecast, then what is impacting it the most? And then let's focus on a Pareto, on the 20-80, like the 20% of data that gives me 80% of the impact. And then we will know there's always a level of inaccuracy, but that's the challenge we have. And if we succeed to make farmers benefit, have one single or whether it's one provider or it's their own on-farm built AI system, but something that helps them basically collect everything in one place, and then with one button through APIs, automatically the data flows to the service providers that give them the insight. That's a beautiful dream. And that's the challenge the AgTech tries to solve for 15 years. But we have a real opportunity in the upcoming 5 years to do so. Where I wanted to go to is actually the remote sensing. You can look at remote sensing as a verification tool, like the farmer declared this. Did it really happen? That's like a real verification. Like, I'm not trusting, or I want to just confirm that I can trust of whatever is declared that it really happened. Or you can look at it as a input source. And then you have to decide, do I use it as an input source for everything or just what it's accurate for? So we know that in Europe, the 60% of the crop area is cereals. So if you can be really good at detecting winter wheat, spring wheat, obviously, you didn't do it by sowing dates. You do the same for barley. You already have a pretty good coverage. Then corn, and then sunflower, and then oilseed rape, and then you have 70%, these are 80% of the surface. So you can then optimize, and then you have the cloud filters, and you need just to be sure that for the region you have the right calibration as well, also on biomass detection, and then you can convert this or use this as an input. Now, is this remote sensing input of better quality than the farmer input? I would not say yes or no. It really depends. We have seen
it's more reliable. It's more reliable because satellite takes a picture every 5 days, and the farmer might not make an input every 5 days.
You might have a cloud there, and then your 5 days are gone, and it becomes 15. But yes, I agree, Yuri. It's for the sake of the exchange of views.
Well, I think part of the value, though, is if you have multiple sources of data, you can check one against the other, and you can determine if you have, let's say, 3 sources of data related to, let's say, yield or to fertilizer consumption or things like that. Then you can then say, well, wait a second, they all true up together and they make sense. Or if you have an outlier and then you want to go and dig deeper to find out what is the cause of that. I mean, I think one thing is that part of this is changing farmer behavior, encouraging farmers to change practices where it makes sense economically and environmentally. Hopefully the two line up, because generally efficiency is good for the bottom line and efficiency is good for the environment. But if we're going to create incentives through this system where someone is going to pay to buy credits based on this kind of modeling, that's going to be an incentive for growers to provide the data and to engage in positive beneficial practices. But Tatiana, who is going to pay for that? I mean, who are the people at the other end who are going to invest in, purchasing the credits? Is it food companies? Is it, financial institutions? Are there private foundations? So who's going to come to the table to finance the whole system?
Just recently, your question is the one that even the EU Commission tried to answer with the CRCF, and last week a lot of MRV providers were also in Brussels to stimulate the demand on that one. But first of all, it comes from the voluntary carbon market in majority. I've seen a study recently from our friends also in Milano, from the Politecnica, who made an overview of all the voluntary carbon market or carbon farming status. I'm not sure if it was European numbers or worldwide. However, the numbers were like 19% is financed by the public sector, So it can be subsidies, research projects, startup funding, but from the public. Then you have something under 2% that comes from private investors, and then you have the rest from the voluntary carbon market. And the voluntary,
when you talk about the voluntary market, you're talking about people that have emissions from, let's say, industrial facilities, for example. No, that's not what you're talking about?
No, not this one, indeed. That's it's like the distinction that the voluntary carbon market and the carbon programs that we are in agriculture financed by is like you're rewarded for doing something good, like for storing carbon and improving your soil and the organic matter.
Mm-hmm.
The other one that you refer to is like the polluter's penalty system.
Right.
As an industry, it comes from the Kyoto Protocol. As an industry, you have a quota for pollution, and if you don't use that quota, you can resell it to someone else. And if you don't have enough, you can buy it from the ETS mandatory system. And so this one is like, if I may simplify, it's like the right to pollute quota.
Mm-hmm.
And when on the other side is like reward for doing something good, storing more. So when I talk about the voluntary carbon market, it's basically no one is obliged to buy your carbon credits, but it's part of your, as an industry, you have an engagement, you have made some pledge, whether it's environmental or social, and you see this as an instrument it's not only PR, but it's an instrument to actually say, to walk the talk. I want to do something good. That's what I'm putting on the table to offset my emissions. The other aspect is that you have the food companies that also want to reduce their emissions or the carbon footprints of their products, but today they're shifting. We're not talking about carbon footprints only. We're talking about regeneratively grown food. So it's basically, we want to have farmers in our supply chain that are resilient, that reduce their risk towards adverse conditions. So if you have a better soil, you have more capillarity, so you store more water. In case of drought, your crop reacts differently. So in theory, you have less losses. So it's also business driven, let's be honest. And ecology works only when there's a business return on investment, unless you put in place a regulation. Right. And that's the big dilemma and challenge that we have in Europe, where if I play according to the stereotype, the Europeans are always we're always a very regulated market and waiting for regulators to tell us what to do and not to do, whereas the rest of the world takes it more freely. It has its constraints, it has its benefits. We'll not debate on this one, but this is the challenge that the European Commission is facing today. With the CRCF, the Carbon Removals Framework, that is a methodology for bringing a little bit of order and recognition for all the carbon efforts made in the European territory in farming. One thing is to define a methodology and say, this is how we're going to recognize it when it's produced here in Europe. The other one is, how are we going to finance it? And this is the big topic today, and that's where your question, Clyde, is very timely. In the future, there will be a lot of carbon units generated in Europe. But when we say carbon units, let's talk about farmers who make regenerative agricultural practices. And then carbon is a proxy to reflect those efforts. But who's going to pay for it? And it's always the same question. Is it mandatory or is it voluntary? For now, it's voluntary. And as long as it remains voluntary, then what's the return on investment for the players in investing in those carbon units in Europe? And that's the whole point and focus of the European Buyers Club that was subject to a meeting last week in Brussels. And they will make decisions in the next 6 months.
Yeah, well, and while we've seen some governments in the world back away from regulation of related to climate change and that. I think there's still a strong desire by ethical investors and also consumers in purchasing food products that have a lower carbon footprint, and so perhaps that is a direction that will lead to further innovation of this kind. Yuri, maybe you want to I haven't heard from you in a second. I just thought maybe you want to jump in at this point.
No, it's a very political and very economically important questions, but I wanna kind of talk about other side of things. So we were talking about who gonna buy those carbon credits, whether it should be voluntary or mandatory, yada yada yada. But right now, those carbon credits, they can generate additional revenue for farmers themselves. I know that in Ukraine, if you are compliant with some of the programs we have here locally, you have extra 40 euros per hectare of actual money coming into your farm. And that's direct, simple value that you can have from using regenerative agriculture in your practices. And that's simple as that. And that technology is already there. It's going to get better, and big enterprises and global companies will have their ECG statements that going to support and buy those carbon credits. And I hope we'll as a society, as a human society, will move forward to kind of being able to understand what global benefit it brings to the whole world.
Yeah.
If I may jump in here, you're absolutely right. And the reason why I look at the role of Armosys as dual is like, on one side, you measure carbon, so it's a defensible metric, so that you can justify that incentive that would come from a voluntary carbon market or regulation. So it's an incentive. Those 40 euros per hectare can also be 100 euros a hectare, depends on the investment you make. At the same time, the farmers are not making a profit with these incentives. It only covers a part of the costs, because if you wanna have some carbon improvements, you need more biomass, and cover crops cost you more than 100 euros a hectare. Sorry for the US audience in bushels per acres, but 100 euros more than 100 euros a hectare. The carbon incentive will not necessarily be 100 euros a hectare every year, actually less, because you cannot have a cover crop every year neither. Then you will have a tillage reduction, but you would have, why would you do that? Because you anyway plan to invest in a direct driller or a disc. You want to speed up your operations. You want to deal with more hectares in a given time because you have less people on your farm. So you basically look at it from an investment point of view, and the carbon incentive is a way to give you the confidence that it's possible to co-finance a bit that transition or those investments, and give you the possibility to learn from others. Because all these programs is basically a community of practitioners, and you exchange. So that's why it brings more. But ultimately, it's about how can we make the farmers profitable? That incentive is just to compensate for something that is not yet profitable. And the other side is this is what Armosys is also developing, or we're able to provide, is how can we make farmers make better decisions so that they produce the same or more with the same input. And that's where the nitrogen efficiency comes into the picture. When your nitrogen unit costs you €1.20, €1.50, you start counting. When you don't have availability in the right time because you have 2 weeks to apply your nitrogen and you don't have it available, well, you start also counting how you're going to react in the following months on your fertilization applications and future investments compared to the commodity price. The beauty of I'll give you one example that I use often to illustrate how far you can go with the right insights. You know how much yield you get, you know how much nitrogen you have applied, but you will not be able to sample your soil every year to know how much of that nitrogen was in the plant at a given time and how much was leaked into the ground or volatilized.
Mm-hmm.
I'm not saying the models are 100% accurate, but at least they give you an information about how, based on the reality of your past season and the reality of your different applications, how much of that nitrogen was taken up by the plant when the plant was in a fertilizer or nitrogen stress, in a hydric stress, and if that uptake was, if that nitrogen was available and uptaken or not available and not, but could have been uptaken at that time. So you can then work all very nicely on these uptakes. Now, where does the role of AI come? You have so many data. You have data on inputs. You need to clean it up. You need to analyze it. You need to make up for what is missing. That's a really good role for AI. And the other one is you have so many outputs and you want to make sense of it without looking at this, at all these data sets. And that's where AI comes into the picture. But at Armosys, we don't touch the pipe. That means we don't, I mean, we don't modify the model itself, ARMOSA. But we do orchestrate everything that goes in and out and how we then present it to customers.
So ultimately, it's a symphony of good choices, we hope. So thanks very much, Tatiana. We did give you a heads up that we were hoping you might be able to provide our audience with some insight into where things are going, a hot take, so to speak. Is there something you could share with the audience?
Yes, you gave me the heads up, and I wasn't sure what to mention first, but I would stay with one thing that I see coming up is the do-it-yourself opportunity that AI offers. It's this debate that you may have, like who is going to be replaced by AI? What's the role of AI compared to in coding? But what's the role of AI in building systems that can scale? And this is a very different topic. And then if you are able to understand the systems and you have a good intuition and you have a good business understanding, or you know what you want to build, then AI is here to build it with you. And it's an opportunity for farmers to basically build something that works for their farm and then be able to plug in to different systems and have access to insights or tools that they otherwise wouldn't have. And that's so I see the opportunity there. Where it goes is have farmers really able to build the products that they need for themselves, and then we all in the ecosystem have to make it available through APIs or other systems. I think there's an American person who's doing this. I don't know them personally. I think his name is Nick Harrop, but they're actually training farmers on how to build their own AI platforms for their own farm. I think this is a wonderful initiative. I'm curious to see how this goes, but if you're a farmer and you're serious about it and you want to survive in this in this world of farm concentration, you have to be an entrepreneur in any case, and a digital savvy one.
I think we're all going to face the challenge of learning more about AI and what works and what doesn't work for us, and farmers, like everyone else, are going to have to start, are going to have to adapt. Yuri, just a final word for you. I think this is an area of interest for you, but what about the interface between the data that Armosys is working on and AI? What is the potential there, and the challenges as well?
Well, first of all, to comment on something Tana mentioned, 100% right now with all AI coding tools, you can prototype and create small applications for your personal use, and I think we will see more and more of that. And it's very interesting to see how it evolves and whether farmers gonna start creating specific tools that works for their farm, or they will try to grow it into standalone products. We'll see about that in terms of what AI can bring and how this technology can enhance foundational models like ARMOSA. Imagine you have ARMOSA, you have 5 more data sources that ARMOSA doesn't use or cannot use or won't use, and you apply it as an additional analytic layer on top of ARMOSA. Or you feed ARMOSA with some data that was generated with AI based on your data sets or your data sources. So there are a lot of opportunities out there. The one thing though I wanna tell to the audience: use AI to prototype and create some POCs and MVPs of products that gonna help you be more productive, more efficient, but do not think that it's gonna replace everything you use right now. Try to integrate what you use right now with stuff you create, because we've seen it a lot of times. AI coded stuff without any technical support cannot survive a test of real world.
Well, yeah, I think everyone has to be cautious, have to be bold in trying to engage with AI, but at the same time cautious that what AI is saying makes sense in the real world. And I think that's the balance. Tatiana, thank you very much for joining us today. I think it's been very interesting conversation. I certainly enjoyed it. We're going to be looking to see how ARMOSA evolves over time. And I think that's one of the things that I see, that this whole space is rapidly evolving, and perhaps is evolving faster than it ever has over the last couple of decades in terms of trying to reliably, defensively measure carbon and other environmental goods and services on the farm. So thank you very much for participating. Yuri, did you have a final word on what's ahead?
Yeah, for sure. First of all, thank you for our audience to listen and tune in into our podcast. I hope you find them useful. We'll get back to you in the first months of summer. So hopefully we're going to have a great weather and great conversations throughout the active season for farming, but hopefully active season for Digital Ag Global as well.
Yeah, and we're coming up at the end of our second season, so that's very exciting for us. And we hope everybody who is in crop season right now has a very good yield coming, and hopefully some of that success is due to some form of digital agriculture. So thanks very much, Tatiana. Thanks, Yuri, and we'll see everybody at the next episode.
Thank you very much.
Cheers.